الله الرحمن الرحيم. السلام عليكم. نتكلم إن شاء الله الليلة عن السيل إنجري. First, we will see overview of cell injury. The cells are active in their environment, can preserve and adjust structure and function to accommodate the change and extravascular or extracellular stresses. So the cell can preserve or maintain the normal homeostasis to stress, physiologic stress or pathologic stimuli, to adapt or adjust the structure and function, and then they can undergo adaptation or التأقلم. Normal structure and function of the cell requires first nuclear function for nucleic acid, protein, lipid, and carbohydrate synthesis. Need also enzyme function for assembly and degradation of organelles and cell products. Need membrane function for transport, metabolic messenger, and for the ionic and fluid homeostasis. The types of cell injury is reversible cell injury, that the cells can return to stable baseline after the injury, can return to its normal and function after hemostasis, after injury. Irreversible cell injury, it is either severe or persistent stress caused by severe or persistent stress, that irreversible if the injury increased within certain limits and the cells difficult to return to normal structure and function. Example in myocardium, muscle of the heart, in case of hypertension, or stenotic valve adapt by undergoing hypertrophy. Hypertrophy, increase in the size of the heart if there is hypertension or stenotic valve. Another is after a period of prolonged starvation or cachexia of myocardium, it can adapt by atrophy, decrease in the size of the heart. If the myocardium subjected to reduced or few blood flow, can adapt this change or this injury by ischemia, which happen from an occluded or blocked coronary artery. This may be reversibly injured, return back to its normal. When, if the occlusion is incomplete, non-complete, or it may undergo irreversible injury, adapt by infarction. Infarction, it is after occluded coronary artery is complete or prolonged. In irreversible injury, the affected cells die. There is two principal patterns of cell death. So the cell can die by two cases. First, necrosis. It is a death of cells in a live tissue, characterized by change in nucleus and cytoplasm. Can occur after loss of blood supply or after exposure to toxins, and this pathway of death may result in cellular dysfunction. Another death of cells is apoptosis. Apoptosis occurs as a result of an internally controlled program. After the dead cells are removed, this occurs in physiologic state when unwanted cells are to be eliminated. Example in embryogenesis. embryo جنين genesis تكوين في مراحل تكوين الجنين, as well as in variety of pathological states at irreparable mutational damage. So what is the causes of injury? Oxygen deprivation or decrease of oxygen, hypoxia or oxygen deficiency can result from ischemia or inadequate oxygenation of the blood, as in pneumonia, or reduction in oxygen carrying capacity of the blood, as in anemia or carbon monoxide poisoning. Chemical agents, glucose or salt, it is concentrated poisons by altering membrane permeability, osmotic hemostasis, or integrity of an enzyme toxic agent in the environment, therapeutic drugs, or are chemical agents. Infectious agent, virus, bacteria, parasite, immunologic reaction, immune system defending the body against foreign bodies, but sometimes immune reaction causes cell injury. Anaphylaxis, like an anaphylaxis to foreign body, protein, or drugs. Loss of tolerance with response to self-antigen is underlying cause of autoimmune disease, أمراض المناعة الذاتية. Genetic defect, that single gene, multiple gene, or whole chromosome abnormalities. Genetic abnormality as congenital malformation, single amino acid substitution in hemoglobin S of sickle anemia. Genetic defect. Nutritional imbalances, like protein insufficiency, pernicious anemia due to deficiency of vitamin B12, affecting DNA synthesis in hematopoietic cells. Excess of nutrition as obesity increases the risk of type 2 diabetes mellitus if the diet also rich in animal fat. Another is physical agents like trauma, extreme temperature, radiation, electric shock. Another is aging. The mechanism of cell injury, so biochemical mechanism, result in cellular manifestation, and the cellular response to stimuli or to injurious agent depend on what? Depend on the type of the injury, the duration of the injury, the severity of the injury, the status of the injury, the adaptability and genetic makeup of injured cells. Example, low dose of toxin and short duration of ischemia may lead to reversible cell injury, whereas longer or larger toxin dose or longer ischemia lead to irreversible cell injury and cell death. So this is according to the duration and the severity of the injury. Ischemia in skeletal muscle can accommodate for 2 to 3 hours without irreversible, whereas cardiac muscle die after only 20 to 30 minutes. This is depend to the type of the organ. The nutritional or hormonal status, this is according to the status. Important also, like glycogen replete, hepatocyte, the cell of the liver, hepatocyte. The glycogen can replete will tolerate ischemia much better than one has just burned its last glucose molecule. Regarding to the initial cause of injury, the response system are vulnerable. Cell membrane integrity, the cellular ionic and osmotic hemostasis, cell membrane, شاء الخلية. ATP generation by mitochondrial aerobic respiration, mitochondria, which synthesizes the ATP. Protein synthesis in the plasmic reticulum. The integrity of genetic apparatus, the nucleus. Cellular function is lost far before death occurs. And morphologic change of cell injury or death. For example, the myocardial cells become non-contractile after 1 to 2 minutes of ischemia, although they do not die until 20 to 30 minutes of ischemia. So function will be lost before the cell die. The general biochemical mechanism within certain injurious agents, the pathogenic mechanisms are well defined. As example, cyanide. Cyanide inactivate cytochrome oxidase in mitochondria. So cyanide affect the mitochondria and lead to inactive cytochrome oxidase, like poisoning of aerobic respiration, which happen in mitochondria with cyanide, result in diminished or less activity of sodium potassium ATPase necessary to maintain intracellular osmotic balance as a result of the cell rapidly swell and rupture and result in ATP depletion or reduction or reduce or less ATP. Certain bacteria can elaborate phospholipase that degradable cell membrane phospholipid. However, in many injurious stimuli, pathogenic mechanisms are incompletely understood. There is several biochemical mechanisms. ATP depletion, like high energy phosphatase of ATP important for process in cell, including maintenance of cellular osmolarity, transport, protein synthesis, basic metabolic pathway. So the ATP is important for transported of protein synthesis and cellular osmolarity. Oxygen deprivation or less also or generation of reactive oxygen species. When a lack of oxygen, this is important for pathogenesis of cell injury in ischemia. But partially reduced activated oxygen species are also important mediator of cell death. The free radical species cause lipid peroxidation and other cutaneous effects of cell destruction. So less of oxygen or deprivation or generation or production of free oxygen, free radical. Loss of calcium homeostasis. Calcium free normally maintained by ATP-dependent calcium transports as concentration up to 1,000 times lower than the concentration of the extracellular calcium. So normally, the cell concentration inside the cell are up to the concentration of extracellular calcium by 10,000, or if intracellular mitochondrial endoplasmic reticulum. So this is maintained by calcium transporter. Ischemia or toxin, a low influx of extracellular calcium. So this is injury happen. Ischemia or toxin. This is the extracellular calcium to influx across the plasma membrane, followed by release of intracellular stock. So lead this to increase the cytosolic calcium. Before we said calcium inside concentration more than outside. So if there is injury, the extra go where intracellular stores, increase the cytosolic calcium. This is activate phosphatase, which promote membrane damage, cause the membrane damage. And ATP is an injury. Another is defect of plasma membrane permeability. نفوذية الأغشية. The plasma membrane may be damaged by certain bacterial toxins, viral proteins, component, physical or chemical agents, secondary that are due to ATP synthesis, calcium mediated phospholipase activation. So loss of membrane barriers lead to breakdown of the concentration of gradient of metabolites necessary to maintain normal metabolic activities. So if the plasma membrane or permeability defect, this is lead to damage of the plasma membrane. This damage caused maybe by bacterial toxin or whatever. And this is lead to injury and breakdown of the concentration of metabolic. Mitochondrial damage. The mitochondrial integrity also critical for cell survival because mammalian cells depend on oxidative metabolism or mitochondria. It is also the target of injury, always target of injury. Intracellular oxidative stress and lipid breakdown products culminate or accumulate information of high conductance channel of the inner mitochondrial membrane. The non-selective pores, the proton gradient, and the mitochondrial membrane to dissipate, and thereby ATP prevention or preventing the ATP generation. So if there is injury in the membrane of the mitochondria, this is affect the ATP generation. And cytochrome C, which important soluble protein for electron transport chain is cytochrome C. It is a protein in the mitochondria important in electron transportation. Also lead to leak out into the cytosol or inside the cell. So this is the cause of cell injury. Ischemia, which happen, death of cells, which happen due to occluded coronary artery, incomplete radiation, inflammation, oxygen toxicity, chemicals, or reperfusion injury. We will see what is the meaning of reperfusion injury, or lead to oxygen deprivation. And this lead to cell injury, ischemia, lead to ischemia because of occluded coronary artery. So the cell die, less of blood, lead to less of oxygen, lead to cell injury. All these clear causes lead to deprivation or reduced oxygen or activated oxygen species or free radical, free oxygen, CO2, H2O2, where OH lead to cause cell injury.